Calculate the pH of a solution that results when 25 milliliters of a solution with a POH is mixed with 45 milliliters of a solution with a pH of 11. So we have 25 milliliters, POH is 12. We're going to mix it with 45 milliliters with a pH of 11. So what does this mean? Well, both of these have H plus and OH minus ions in here. So let's figure out what the concentration is in these, and then we're going to mix them together. And when we mix them together, we're going to have 70 milliliters, and we're going to have some number of moles of everything in here. So in this case here, we're going to say that the concentration of OH minus is going to equal 10 raised to the negative 12. So when we do that, calculator went off, 10 raised to the negative 12, we get a concentration of 1 times 10 to the negative 12 for the OHs, which means that's the H plus concentration. Well, if the POH is 12, then the pH is 2, because those have to add up to 14. So the H plus ions is 1 times 10 to the negative 10 to the negative 2, which is going to be 0.01. That's the H plus. Okay, on this one here we have a pH of 11, so we know that that means that the concentration of H3O plus is 10 to the minus 11. That means the concentration of the OH minus is 10 to the minus 3. Okay, now these small ones, 10 to the minus 12 and 10 to the minus 11, they are going to, thinking about this, if I wanted to add how much H plus I have 0.01 moles here, a 0.01 molar. In this case, I have 0.000000000001 molar. This is going to be negligible. Okay, we can look at it, but when we add these in here, we're going to get all of these ions get dumped in here, and we have to remember that we still have to keep the pH and the POH adding up to 14. So I like to do this in moles, and I know you can do it as a dilution, but I'd prefer to do this as moles. So let's find the number of moles of H plus. That's 0.01 molar times 0.025 liters, and that's going to equal 0.00025 moles. Okay. Let's find the number of OH minus ions in here, right? So we have 1 times 10 to the minus 12 times 0.025, and clearly this is going to be very small. We have 2.5 times 10 to the minus 14 moles. So that becomes negligible when we have to do an addition problem, because the sig figs I will lose when I try to add something like this with something like that. I would lose it. So this is OH moles, and this is H plus moles in my first beaker. In my second beaker, my number of H plus moles is going to be 1 times 10 to the minus 11 times 0.045, which is going to be 4.5 times 10 to the minus 13, and that's my moles of H plus. And my moles of OH minus is going to be 10 to the minus 3 times 0.045, which is going to be 4.5 times 10 to the minus 5 moles. Okay, now what's going to happen? I'm going to pour these in here, and I'm going to have H plus ions and OH minus ions getting dumped in together. And they're going to react, just like they did in the last example, to create water. So if we look at these, we have H plus OH minus makes water. And then the autoionization will occur. So the first thing we're putting in 0.00025 moles of H plus. We're going to ignore this since it's so small. We're putting in 0.000045. Sorry, I have to make sure I have the right number of zeros. Okay, so this one is smaller. That means that that's limiting. So when we use all those up, we'll have to subtract that amount from this. So we have 2.05 molar, times 10 to the negative 4 moles of H plus. So after these react and neutralize each other, what would be left in here is 2.05 times 10 to the minus 4 moles of H plus. Plus these very small amounts of the OH and the H plus, but those are negligible compared to this. This is going to be the driver since it's times 10 to the minus 4. Okay, so the question says, calculate the pH of the solution that results. So now we've calculated the H plus ions that are left in there. This is the H plus ions in excess after this reaction. So the pH will equal negative log of 2.05 times 10 to the minus 4. And when you do that, oops. You're going to get a pH equal to 3.7. Actually, how many sig figs? We should have 2. That should be right. Okay, so we have pH of 3.7.